All right, today we're going to look at dilation. So dilation is taking an image and enlarging or reducing the image. So first we're going to look at enlargement. So we're going to find a scale factor, or we're going to use a scale factor of 2 for our triangle and dilate it. So scale factor means we're going to multiply by 2. We're going to multiply all the points by 2. So we're going to find our points. So A is at 1, 4. B is at 6, 1, and C is at 3, 1. And then we're going to multiply each dimension by 2. So 2 times 1 is 2, 4 times 2 is 8. 6 times 2 is 12, 2 times 1 is 2, 3 times 1 is 6, 2 times 1 is 2. And so when we graph our image, we will now have a larger triangle. So you can see that the image has enlarged. And the 2 means it is doubled in size. So let's look at this one. So now we're going to change by a scale factor of 4. So D is located at 1, 2. E is at 3, 2. F is at 2, negative 1. And G is at 0, negative 1. So with the scale factor of 4, we're going to times everything by 4. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 2 is 8. 4 times 2 is 8. 4 times negative 1 is negative 4. And 0 times 4 is 0. Negative 1 times 4 is negative 4. And so then we're going to graph our new image. And so this image will be a lot larger because it is enlarging, and it's increased in size by times 4. So that means this has quadrupled in size. So you can see that the image has gotten bigger. So let's look at when we find the dilation. So first we're going to look at the points. So J is at 1, 0, K is at 2, 2, and L is at 2, 0. And then we have J with a little mark on it. We call that prime. So this basically means it's the new figure. So J prime is 5, 0. K prime is 10, 10. And L prime is 10, 0. And so we look from our original figure to our new figure. And we went from 1 to 5, 2 to 10. So that means we are timesing everything by 5. So my scale factor is 5. So now let's look at the reductions. This is where the image is getting smaller. So similar to the last side, we still have a scale factor, but the image is going to be smaller. So find the point. R is at 0, 3. S is at 6, negative 6. And T is at negative 3, negative 9. So with a fraction, we're still timesing it by 1/3. So we're going to do 1/3 times 0, which is 0. 1/3 times 3, which is 1. So we are multiplying 1/3 times 3, and that will turn out to be 1. Another way is looking at it by dividing it by 3, cutting something into thirds. So 6 would turn into 2, negative 6 would turn into negative 2, then we have negative 1 and negative 3. So when we graph it, we can see that we have a smaller triangle, and this triangle is now 1/3 the size of the original. Next one, we have a scale factor of 1/2. So M is at negative 4, 12. N is at 8, 12. P is at 4, 4. And Q is at negative 4, 2. So again, scale factor of 1/2. We're going to times everything by 1/2. So negative 4 times 1/2 will turn out to be negative 2. And just like above, when I'm halving something, that's the same thing as saying divide by 2. So 1/2 times 12 is 6. 1/2 times 8 is 4. 1/2 of 12 is 6. 1/2 of 4 is 2. 1/2 of negative 4 is negative 2. And 1/2 of 2 is 1. So our image on this one will be 1/2 of the original image. All right, and then for our last one, finding the scale factor. So find the points first. We're at 0, 0. V is at 4, 8. W is at 12, negative 4. U prime is at 0, 0. V prime is at 1, 2. And W prime is at 3, negative 1. So we're looking to see what's happening between our original to our new. So 4 to 8, 8 and 2, it's all dividing by 4. So our scale factor is not 4 since it's a division because scale factors multiply. So the opposite of dividing by 4 is multiplying by 1/4.